Okay, so today's lesson we're carrying on with sequences, so all the questions will be in the video, but I will also attach them as a separate sheet as well in case you'd rather work from that. Okay, so with generating sequences, what we're doing is we're using algebra to form a sequence. So like what we were doing last lesson where we had a sequence and we were spotting patterns, this is quite similar. So with this we'll be using substitution, so we did a revision lesson on that a couple of lessons ago, so that'll be really useful. If you do need to go back and have a quick watch of that, just to recap before today's lesson, that might be wise. Okay, so with this, when we're generating terms, we'll be given an algebraic formula like this one at the top here, the n plus 2. So this is a formula, and we can see it's got this n in it. So we usually use the letter n, and that is the position in the sequence. So for the second term in the sequence, you'd have n equals 2. For the first term in the sequence, you'd have n equals 1. Let's say you're looking for the 100th term in the sequence, you'd have n equals 100. So this is just how we write, we represent the sequence as algebra, so we write it like this. So what we're going to be doing in today's lesson is we're going to be looking at an algebraic formula and seeing how we can work out the sequence from that formula. So the first one we're going to look at is, you'll get a question like this: find the first 5 terms of, and then this sequence here, but in the algebra form, n plus 1. So what we need to do is substitution. So the first term, we're going to do n plus 1. And because it's the first term, we say n equals 1. So what we're doing is we're doing n plus 1, and because we're doing the first term, we use n equals 1. So we end up with 1 plus 1, which is 2. So for the second term, so that was the first term, so our sequence is going to start 2. So for the second term, we're going to do n equals 2. So for the second term, bear in mind we're using this formula here, n plus 1. So we're going to do n plus 1, and we know because it's the second term, n equals 2. So we're going to substitute in 2 plus 1, and then from there we've just got 3. So the second term in our sequence will be 3. Okay, let's have a look at how we do the third one. So with the third one, because it's the third one in the sequence, we've now got n equals 3. So you can spot this pattern here. So first n is 1, second n is 2, third n is 3. So to work out what the third term would be, we're going to use our algebraic formula here, which is n plus 1. And because we're doing the third term, we're going to substitute in n equals 3. So wherever we've got an n, we replace it with a 3, so we do 3 plus 1, which is 4. So the third term in our sequence would be 4. You might have spotted a pattern here, so we've got 2, 3, 4. See if you can predict what the next one will be. So the fourth term in the sequence, so that is n equals 4, because it's the fourth term. So we write fourth term equals, and again, we write out our algebraic formula first. So this is how we represent the sequence in algebra, so n plus 1. And because we're doing the fourth term, we know that n equals 4. So we substitute in, wherever there's an n, we replace it with a 4. So we do 4 plus 1, which is 5. So well done if you managed to predict 5. If you didn't, see if you can predict the next one. So we've got 2, 3, 4, 5. So the fifth term, so that is n equals 5. So again, we write out fifth term equals, and then we're doing n plus 1. And then because it's the fifth term, we're substituting n equals 5. So wherever there's an n, we swap it for a 5. So 5 plus 1 equals 6. So we've now got the first 5 terms of our sequence there. So we can tick off that question. We can see we've got a sequence with a good pattern: 2, 3, 4, 5, 6. So we've got, so that should be 2, 3, 4, 5, 6. So we've got our sequence sorted there. Okay, so let's have a go at a slightly trickier one now. So 2n. So remember, when we've got 2n, what that really means is 2 times n. So I'm just going to do the first 3 of this one. I'm not going to do all 5. Okay, so the first term, so that means n equals 1, because we're doing the first term. So what we need to do, we write out our formula 2n. So first term equals, so that's 2n, so that is 2 times n, and because it's the first term, we know that n equals 1. So what we do now, wherever we have an n, we swap it for a 1, because we do substitution. So we've got 2 times 1, which is 2. So that means our first one in the sequence is 2. So the first term in the sequence is 2. So let's have a look at the second one. Second term. So for the second term, that means it's going to be n equals 2. Because if you remember, n is the position in the sequence. So we're the second position, so that means n is 2. So second term then. So again, we start out by writing out our algebraic formula. We always start by writing out the formula. And then if it's got a multiplication, we write it in full, so it's a bit more obvious what we're doing. And then lastly, we need to do the substitution. So now we've got 2 times 2. So that will be 4. So right in 4, we've got our first 2 terms of the sequence. Let's do one more. So third term. So this one, what would n be? So for the third term, n would be 3. So third term, again we start out by writing out the algebraic form, so 2n, which is 2 times n, and then from there we substitute in n equals 3, so we've got 2 times 3, which is 6. So we've worked out our first 3 terms of the sequence. So you can see again we've got a pattern there, 2, 4, 6. So actually, you don't need to know this for today's lesson, but whatever number is in front of the n, that is what our sequence will go up in. So because this is a 2, that means our sequence is going up in 2s. So you can check your answer like that as well. Okay, on to a slightly more complicated example. So with this one, we can see that our formula has got 2 parts. So we've got this first bit, the 3n, and the second bit, the plus 4. So what we're going to have to do is we'll think about what 3n actually means. So 3n is 3 times n. So what we're going to have to do for each term, we're going to have to do 3 times n and then plus 4. So let's start. So we've got the first term. So this is position 1 in the sequence. So what we always do is position 1, we write n equals 1. So then we start calculating the term. So we do first term equals, and then we write out the full algebraic thing. So 3 times n plus 4. And then from there we can substitute in, so we know that n equals 1 for the first term, so we're going to do 3 times 1 plus 4. And then lastly, 3 times 1, so that is 3. So we've got 3 plus 4, which gives us 7. So the first term in our sequence will be 7. So all we've done, same process, we've substituted in to the formula. So let's have a go. Second term. So for the second position, that tells us n equals 2, because we're at position 2 in the sequence. So second term, so that is going to be 3 times n plus 4. So this is our formula from up here. So that tells us what the sequence is. So we're going to do 3 times 2, because we're at n equals 2 now, plus 4. So 3 times 2 is 6. So we've got 6 plus 4, which is 10. So our second term is 10. And we can see that this is increased by 3, so it's gone up by 3. That is because the number in front of the n is a 3, so we could actually make a prediction of what the next one is going to be. So because we've got a 3 in front of the n, it's going to be plus 3. So let's predict 13, and let's check if that is correct. So third term. So for the third term, that will be n equals 3, because we're at position 3. So third term then, we do 3 times n plus 4, because that's our formula from up here. So 3 times n plus 4, so that's going to be 3 times 3 plus 4. And then remember, whenever we have a multiplication and addition, we do the multiplication first because of BidMass, so that is 9 plus 4, so that is 13. So we can see that our prediction was correct. So because we're adding 3 each time, and you can do that as a little shortcut. If you spot there's a 3 in front of the n, you know it's going to add 3 each time. Just one thing to be wary of though, there aren't any in today's example, but if it were minus 3, that would be decreasing by 3. So just be careful, if you've got a negative in front of the n, it's a different rule, but you can still do it using the method that we've been doing here, where you're substituting in. So just be careful, but the substitution method's really good. Again, onto a slightly trickier one. So we're on to the tough ones now. So here we've got one, and we can see we've got two parts. We've got 4n, and we've also got minus 1. So what we're going to do is we're still going to be doing substitution, but there's going to be a little bit more of a complicated substitution. So again, I'll just do the first 3 for this one. So we're going to do 4n minus 1, but the method is still the same. So first term, so for that tells us, because it's the first term, n is going to equal 1. So from there, we're going to have to do, so we write first term equals, then just like before, we write out the algebraic form first. So what this is, so 4n, that is 4 times n, and then after that we're going to minus 1. So let's start by working out 4n. So that's 4 times n minus 1, and we know that n is 1, so we're going to do the substitution, so we're going to do 4 times 1 and then minus 1. So 4 times 1 minus 1, so we've replaced the n with a 1 because we know that n equals 1. I'm just going to move to below now, so we're going to do 4 times 1, which is 4, and then minus 1, so that is from here. So we've got the 4 times 1 is 4, the minus 1 stays there, so we do 4 minus 1, which is 3. So you can see there's a couple more steps then. It's because we've got two parts now. We've got a 4n and we've got a minus 1, but our final answer is 3, so the first term would be 3. So let's do the second term now as well, and we can maybe do it in a couple of steps. So second term, so what would n be for the second term? N equals 2, because n is the position in the sequence and we're in position 2 now. Okay, so second term equals, so again we write out the algebraic one first, as we always do. So 4n minus 1, and we'll write that out 4 times n minus 1. So then we substitute in n equals 2. So we're going to do 4 times 2 minus 1. So 4 times 2 is 8, and then we've got minus 1. So we've got 8 minus 1, which is, I'll just do it on the same line, 7. So our sequence then goes 7 for the second term. And if you remember the last one, I said we can look at the number in front, and that'll tell us what it goes up by, and this is 4, so that also works here. So you don't need to know that for today's lesson, but that's a really useful check. Okay, and the third term and the last one that we're going to do with this example. So what would n be for the third term? We're in position 3, so that means that n equals 3. So you can see when we generate in terms of a sequence, we're doing the same process each time. We're just looking at the different positions and then trying out the different values of n. So third term equals, so again start out always by writing the algebraic form 4n minus 1, and then writing it as clearly as you can. So this is 4 times n minus 1, so we know what we've got to do. So the first thing is, let's do substitution. So we're substituting in n equals 3 because we know that we're in the third position now. So we do 4 times 3 and then minus 1. Now we can do this calculation. So remember, we do multiplication first because of bid mass. So 4 times 3 is 12 minus 1. So our last one would be 11. So we can write 11 there now, and also we can just check that this should be plus 4, and we can see that it is. So we've got our first 3 terms. So we've worked out our final answer to that one. We've got all 3 of the terms. So for the questions today, we've got 2 sections. So this is section 1. We can see we've got 4 questions. So 1, 2, 3, and 4. What you need to do is work out the first 5 terms of these sequences. So this one has been started for you. So this is 6n minus 3. So they've started working on the first term. So that is n equals 1. So they've done 6 times 1, because it's 6 times n. So it's 6 times 1, and then minus 3. So 6 times 1 is 6, and then minus 3. So we've got 6 minus 3, which is 3. So our first term of this sequence would be 3. Okay, so have a go at these. So pause the video, have a go at these, and I'll put the answers up on the next slide, and then there'll be a few more questions after that to have a go at to get the extra practice. Okay, here's the answers for those previous ones, so check you've got them right. And then before you move on to the next section, just have a quick reflect on how you found those first ones. Check you've got them right if you didn't get them right, so if you can work out what mistake you made before going on to these next ones. Okay, so here's the last set of questions. So we've got 8 questions. So the first one's a little bit easier and they do get a bit trickier as you go through. And answers are up now as well. So here's the answers. Check you got them right. And if you have any questions, feel free to send me an email and I should be able to help out.